Okay, welcome back, guys. We have a question from chapter 4, and we need to determine the moment about point A of each of the three forces acting on the beam. So we have three different forces, F1, F2, and F3. And we need to find a moment about point A. And as always, we're going to use the 2D shortcut that we have for finding the moment about point A. Before we start the question, please make sure to subscribe to the channel and share this content with your friend that might find this helpful. And as always, let me know if you have any specific question in your mind and we can cover it in the next videos. And let's start with the first moment, or the moment of F1 about point A. So what we are looking for is the force and the vertical distance, or the position vector, for finding the moment in 2D. And let's find the moment of F1 about point A. As always, we're going to call counterclockwise positive, and the force that we have, we'll see that the moment will be clockwise, as this is the direction. So we have a negative sign 375 times the distance, which is the distance from the vertical distance from point A to the line of action of the force, which is this line that I'm showing in here. And the vertical distance is this distance, or 8 feet. And if we calculate this, we'll get minus 3,000 pound-foot. And we know 1,000 pounds is 1 kip. So this will be 3 kip. And this negative sign in here shows the moment is clockwise, or we can just write in front of it clockwise. So that was the first one. Let's move on to the F2. So I'm going to show it in red. We're going to find the moment of F2 about point A, and again counterclockwise positive. And for this, we need to find the x and y component of this force. And if we do that, we'll see that the x component, so let's call this F2x, and this to F2y. We see that F2x won't make any moment, since R and F are along one line. So the sine of that angle, which is 180, will be 0. And for finding the moment, we know we have R cross F, or R times F times sine of alpha. And from here, if alpha is 0 or 180, the sine will be 0. That's why the F2x won't make any moment. But if you look at F2y, again, we have the same clockwise moment about point A. And this time we have to find the F2y, which will be, if we look at this right triangle here, we are looking for this part, which will be 500, which is the hypotenuse, times the cosine of this angle, which will be 4 divided by 5. So we have 4 over 5, and that would be the force. And for the distance, we basically have distance from here to here, which is 8 plus 6, which will be 14. And if we calculate this, we'll get minus 5,600 pound-foot. And if we want to report it in kip, we'll have minus 5.6 kip, and the moment will be clockwise. Okay, now let's move on to the moment of F3 about point A, counterclockwise positive again. And if we look at this, we'll see that we're going to break down again to x and y component, but this time for F3, we have a distance of 0.5 foot for the x component, which means we will have another moment for F3. So we can start with the x component. So if we see this time, the moment will be counterclockwise, as we see that we have a distance, this little distance in here, which is 0.5 foot. So we'll have a counterclockwise, so it will be positive. So let's figure out the x component of the force. So we have 160 times This will be the x component, or f3x, which will be 160 times sine of 30 degrees. And for finding the distance, what we are interested is the distance to the line of action. This will be the line of action, and the distance will be the 0.5. And let's move on to the second one. This time the moment will be the moment of f3y will be negative because it's clockwise, so 160, and the y component will be cosine of 30 degrees, and the distance will be 8 plus 6 plus 5, which is 19. And if we calculate this, we'll get minus 2593 pound-foot. And if you want to find it in kips, just divide that number by 1000, so we'll get 2.593 kip foot. And since we got a negative sign, the moment still is clockwise. So that would be the final answer for this question. All we need to do is to be careful about the distances of the point that we are finding the moment about and the point that the force is applying. So for the F1 and F2, they are all in the same x position. They are in the same line. That's why we don't have any moment from F2x about A, but here, since we have a 0.5 foot distance, we need to count for the moment of x component of the force. And that would be the final answer for this question. Please make sure to subscribe to the channel and let me know if you have any question in the comment section below. And you guys take care. I'll see you in the next one.